Now we're recording.
Hey.
You can hear it.
Yeah. So here we go. Properties of limits. Finding limits by direct substitution. So for many well-behaved functions, evaluating the limit can be found by direct substitution. So what I mean by that is that if you have the limit as x goes to some value, direct substitution says you take that value and just plug it into the function. Okay? That's all direct substitution is you just plug in that function value. Or plug that value into the function, I should say. So many functions, such well-behaved functions, are continuous at C. Okay, so as long as it's continuous, then you can plug it in. If it's not continuous at that point, then we're going to have to try something else. So we'll study continuity of functions in section 2.3, that little scrolly looking thing, the curvy two S's kind of stacked on top of each other. That means section. Okay, you won't really see me write that very often, but in college you may see that. Okay, so that means section if you ever come across that again. So that's section 2.3. Okay, just a heads up, FYI. All right, so the following theorems describe limits that can be evaluated by direct substitution. Let b and c be real numbers, let n be a positive integer, and let f and g be functions with the following limits. So the limit as x goes to c of f of x is equal to L. So as x approaches c of the f function, we're going to the y value of L, and the limit as x approaches c of the g function is equal to k. Okay, so those are the numbers. Those are my definitions, so to speak. Okay, so the first one, the limit as x goes to c of b is equal to b. And that should kind of make sense, right? Because this is a function on the inside. That's a function on the inside. So that's the function y equals b. So if you're thinking about the equation y equals b, what does that look like? A line, a horizontal line, right? So if you're tracing your horizontal line to a certain x value, I'm tracing the line and it's that y value, right? So it makes sense that if you have a constant like b, you get b right back because you're tracing that horizontal line. Does that make sense?
Yeah.
Okay. That one should kind of just make sense. Okay. So the limit as x goes to c of f of x times g of x is equal to L times k. What did we say above that the limit as x approaches c of f was? No. At the top of the box. The limit as x goes to c of f of x was equal to L. And the limit as x approaches c of g of x is equal to k. So if you multiply two functions, you multiply their values. If you divide two functions, you divide their limits. Okay, what they're equal to. Make sense? Okay. The limit as x goes to c of x is equal to c. The equation y equals x, what does that look like? A diagonal line through the origin. And so whatever you plug in for x, you get that back for y, right? Okay, it's that diagonal with the slope of 1 through the origin. So if you plug in 1, you get 1. If you plug in 2, you get 2. If you plug in 3, you get 3. Right? So if you're tracing that function, you're just going to get whatever you plug in. The limit as x goes to c of b times f of x. If you're multiplying by a scalar, you multiply your value by a scalar. So like over on the test, right, you multiplied by the scalar of -2, so that moved that value. Okay, so if you multiply by a scalar, multiply your answer by a scalar. The limit as x goes to c of f of x plus g of x. If you add or subtract your functions, you add or subtract your values. If you have your function to a power, the limit as x goes to c of f of x of r divided by s, you just raise your value to that power. Okay? All right. So let's try some. Use the given information to evaluate the limits. The limit as x goes to c of f of x equaling 2, and the limit as x goes to c of g of x equaling 3. Okay? So we're going to use these two ideas in the problems below. Below it, right below it. So the limit as x goes to c of 5 g of x. What is the limit as x goes to c of g of x?
Okay. No. That's 3.
3. The directions for this problem just said that the limit as x goes to c of g of x was 3. So that g of x is 3, but I have that scalar of 5, so you just multiply by the scalar. So what's 5 times 3? 15. So my answer is 15.
So, when you're recording this, it records the voice and when you write?
Yes. And it just got you saying that. Okay? So if you zoned out on this example and didn't know what to do, you could always replay this later. Right? Oh yeah, and I know you all watch them diligently, right? Oh yeah. Probably not. Okay, so the limit as x goes to c of f of x plus g of x. What's the limit as x goes to c of f of x? It's just 2. And the limit as x goes to c of g of x was 3. So what's 2 plus 3? 5.
It seems like it's gonna get hard real fast.
This is it.
This is the pinnacle of calculus, guys.
Pinnacle.
This is the building blocks. This is the foundation of calculus. Okay. The limit as x goes to c of f of x times g of x. So what's the limit as x goes to c of f of x? What's the limit as x goes to c of g of x? What's 2 times 3? Okay. D. The limit as x goes to c of f of x divided by g of x. What was f of x equaling? What does g of x equal? 2/3. Mm-hmm. Okay. When dealing with a constant value for c, realize that the properties in the box above basically allow us to evaluate a limit by plugging in the value of c everywhere there's an x. Be careful with your variables though. Okay? So 11a, find each limit. The limit as x goes to 1 of negative x squared plus 1. So direct substitution says you just plug in 1 for the x. Since x is going to 1, we plug in 1 for x. So negative 1 squared plus 1. So what's 1 squared? What's negative 1 plus 1? 0. So 0 is my answer.
Second.
If it wanted the negative on the inside, it would have put this in parentheses. Okay? So, yeah, the negative's on the outside unless it's denoted with parentheses like that. Okay? All right. B. Plug in 3. So the square root, the limit as x goes to c of the square root of x plus 1 divided by x minus 4. So you do the square root of 3 plus 1 over 3 minus 4. What's 3 plus 1? 3 minus 1, or 3 minus 4 is negative 1. Square root of 4 is 2 divided by negative 1. Negative 2. Okay? Okay, C. Any questions so far? Okay, the limit as h goes to 0 of 3h squared plus 2h. So anywhere there's an h, you plug in 0. So 3 times 0 squared plus 2 times 0. 0. Tough stuff.
Wait. Oh, yeah, of course.
Riley? I don't think Kamasi wants to be in your snaps.
I do. Watch.
Riley, put your phone away. Thanks. Okay, D. Now here's where it gets a little tricky. The limit as h goes to 0 of 3x squared minus 2xh plus 5h. Okay, it's the limit as h goes to 0. So the only thing that gets 0 is h. You don't touch the x's. They just go along for the ride.
Watch out.
Okay. So 3x squared minus 2x times 0 plus 5 times 0.
3x squared
3x squared.
minus 0.
So you just put 3x squared. Okay? Any questions on those? Okay. Let's look at the next page. Other strategies for finding limits. If a limit cannot be found using direct substitution, then we will use other techniques to evaluate the limit. Keep in mind that some functions do not have limits. Okay, so no matter what we try, some of them just do not have limits. Okay? So if direct substitution yields the meaningless result 0 divided by 0, then you cannot determine the limit in this form. Okay? The expression that yields this result is called an indeterminate form. And if you have an indeterminate form, indeterminate form, you need to do something else. Okay, you have to do something else. That'd be interesting. Okay, so when you encounter this form, you must rewrite the fraction so that the new denominator does not have 0 as its limit. One way to do this is to cancel like factors. Another way is to rationalize the numerator. And the third is to simplify the algebraic expression and evaluate the limit by direct substitution again. So the first thing we try is direct substitution. If direct substitution doesn't work, we got to try something else. Okay? And one of those try something else is cancel and factor, rationalize, or just simplify the expression algebraically. Okay, so one of those three, if it does not work. So find the limit as x goes to negative 1 of 2x squared minus x minus 3 divided by x plus 1. So you plug in the negative 1. What do you mean? Okay, but are you thinking it? So you got to write it.
Oh, I'm just saying.
I know. Okay. So you plug in the negative 1. So we try direct substitution and we try plugging it in, but we end up with a plus 1, minus 3, and then a 2, 2 plus 1 minus 3 on top, which is 2 plus 1,
0.
minus 3
0.
is 0, negative 1 plus 1 is 0. Yes, indeterminate form. Yes.
You can't divide a number by 0.
Good job, Amasi. I'm so proud of you.
Last week I was for 0.
Boom! It blows up. You're welcome, Carl. Making sure you're awake. Mhm. So, since it went boom, we got to do something else. Right, Trenton? Right? Do you know what I said? Good idea. Yes.
For something else, I factored the top and then, what's it called? Where you
Cancel?
yeah.
Yep. So Carl's on the right idea. We try factoring the top. Okay? So one of the things we try first is try factoring. And so if you look at that, you're thinking, okay, it's a quadratic. Chances are I could probably factor it, so we try factoring it. Okay? So the limit as x goes to negative 1. Teach me how to factor. Teach me how to factor. Everybody factor. Everybody factor. Everybody factor. Check my work when I factor. How do you factor that?
Yeah, something like that.
Yeah, good. 2x minus 3 times x plus 1 divided by x plus 1.
I can't do it in my head when there's a number on the exponent.
Well, what are your...
Or not the exponent, the first term.
Okay, so what are your factors of 2?
2 and 1.
So put 2 in one
Okay,
spot.
2, that's the easy one.
Okay.
But still, I just wouldn't do it. I'd have to write it out.
Okay, that's fine. You can write it out. I'm not going to.
Oh.
You're welcome. Okay. Anything cancel?
No.
X plus 1's cancel. So you're left with the limit as x goes to negative 1 of 2x minus 3 Okay? So we got it all simplified as much as we can. So now we try direct substitution again. So try direct substitution. We take that negative 1 and we plug it in for the x. Will this give me a 0 over 0? Nope. So we got to simplify it and evaluate it. So negative 2 minus 3 is negative 5. So my answer for this limit is negative 5.
Look at that.
Boom, baby. Hmm?
Talking stuff.
Autumn, what's up?
She doesn't
I
want
just feel like this is just a bunch of made up rules.
What do you mean made up rules? Like you what? Okay. So let's try the next one.
First we close on the I, and then we try.
You would have to close it.
Wait, we didn't.
So here we go. Let's try this one now. The limit as x goes to 3 of the square root of x plus 1 minus 2 divided by x minus 3. Okay. So we try direct substitution. Square root. Because we're thinking, okay, so if this is like any math class, chances are that it's not going to work and I'm going to have to do what he's teaching today, right?
Yeah.
So, but the sequence of trying limits is you do direct substitution first, then you do something else. So we try direct substitution. Direct substitution leads to the square root of 4 minus 2 over 3 minus 3, which is 2 minus 2 over 3 minus 3. And what do you get there? 0 over 0. And it goes boom! Don't try typing that in your calculator. If you try typing it in your calculator, you're going to owe me $150.
Okay.
Oh, you all owe me $150. And so since it went boom, since you can't divide by 0, it will blow up. So now we have to do something else.
That might be dead for you.
Probably. So we got to do something else. What could we do?
Anything else besides that?
Hmm? If you squared the fraction, and you did like this, you'd still have a middle term, right? Because you'd have to FOIL it, and you'd still have that square root on top. So that we probably don't want to do that. Any other ideas?
Multiply the top and bottom by x minus 3.
If we do x minus 3, we're still going to have a square root, right? Because we'd have the square root of x plus 1 times x. So that didn't get rid of the square root.
Continue.
So what could I do? Any ideas? Okay, so what if we try and rationalize the numerator? And the way we can rationalize the numerator is
Jeez, Riley. Come on now.
multiplying this by the square root of x plus 1 plus 2. So multiply the top and bottom by the square root of x plus 1 plus 2. Okay?
Did you write Madrid?
Hmm?
Did you write Madrid?
No, I forgot the letters.
Okay, I learned like
Okay, so we got to multiply this out. Okay, if you think about multiplying this out, I'm going to show some like scratch work down here. If you have the square root of x plus 1 minus 2 times the square root of x plus 1 plus 2, that's a difference of squares, so we don't end up with a middle number. What we end up with is the square root times the square root, which is just the inside, x plus 1. Outside terms, so plus 2 times the square root of x plus 1, negative 2 square root x plus 1, and then the negative 4. So these ended up canceling out, and you're just left with x plus 1 minus 4. Does that make sense?
Can you explain the first part one more time?
Why are we multiplying that? That's how we're going to rationalize the numerator.
How'd you multiply?
That's kind of like the conjugate. Change the sign in the middle, make a difference of squares.
No,
get that part, but I'm saying, like, why did you multiply it by x plus 1 plus 2?
Because of what I just said.
Conjugate.
Yeah, think of it as kind of like a conjugate where you just change the sign in the middle. And when you do that, then you can get rid of the square root in the numerator. Okay? All right, so what do we end up with? Well, we just kind of found it. You have the limit as x goes to, what is it, 3? Of x plus 1 minus 4 over, what do we have on bottom, x minus 3? Don't do anything with the denominator, we're just going to leave it. And we carry that over. Square root of x plus 1 plus 2. Okay, so that just carries over.
Can you zoom back into the other thing again?
Said no.
Yeah.
Is that what you were looking for? Okay. All right. So we simplify the top. Don't do anything to the bottom yet. What's x plus 1 minus 4? X minus 3. Why did I put that there? X minus 3 on top. On the bottom, x minus 3. And then square root of x plus 1 plus 2. What do you see?
X minus 3?
You have double vision? Seeing it twice? You're not seeing it twice, you only see it once? I see it twice. I see it on the top and the bottom. So since I see it on the top and the bottom, it cancels out. I'm left with the limit as x goes to 3 of 1 over the square root of x plus 1 plus 2. Okay? So we got it simplified down as far as we can. Now we're going to try direct substitution again. I try plugging it back in and seeing if it works. If it works, we're on this right track. If it doesn't work, well, maybe the limit just doesn't exist. Okay? So this is 1 over the square root of 4 plus 2. What's the square root of 4? And then, yep, it's overall, it's 1/4. Okay? Any questions there? Okay, next one. What?
I'm just guessing that this one doesn't work. We haven't happened yet.
Wait, you're guessing this one does work or does not?
Does not work.
Yeah, probably guessing right. So, limit as x goes to 0. I'm going to rewrite this one to make it better understanding, make it a little bit easier to understand what's actually the problem looks like. We've got fractions on fractions, right? On fractions. Stacks on stacks on stacks. We have the limit as x goes to 0 of 1 divided by x plus 4 minus 1/4 all divided by x. Okay.
Lovely.
I know, right? So we try direct substitution. We're going to try plugging in 0. So 1 over 0 plus 4 minus 1/4 all over 0. Well, what does that equal? 0 over 0. Boom! It blew up. So that means we got to do something else.
Boo.
You mean yay?
Sure.
So we got to do something else. Okay, so what could we do? What? Could you write it in fractions? Get rid of the fractions? Yeah, we're going to try that here in just a second. We're going to simplify this algebraically. So this is equivalent to the limit. Can you guys see the orange? Or would you rather me use a different color? Different, okay.
Change it.
The limit as x goes to 0 of 1 over x plus 4 minus 1/4. Okay, now let's think about this. If you're dividing by a fraction, how would you do that? If you divide by a fraction, what would you do? Yeah, multiply by the reciprocal. So if I divide by x, that's the same as multiplying by 1 over x. Does that make sense?
Yes.
Okay. So what I want to do is I want to combine these fractions.
Combine them.
Okay, let's try combining these fractions. And so when I combine the fractions, I've got to get them in the same denominator. Okay, I've got to get the same denominator. So to make the same denominator of x plus 4 and 4,
Right second.
the right side, we'll do this left side first. I multiply the top and bottom by 4. And then I would need to multiply this one by x plus 4. Does that make sense?
Yeah.
Because when I do that now, notice that both of them on the denominators have an x plus 4 and a 4. Okay, so now they've both got the same denominator.
Why? I remember doing this last time. I remember, why would you you already have your x plus 4.
But not in the 1/4.
Yeah, you just multiply that by x.
No, because I need that x plus 4 with it. I need that whole expression, not just 4x.
Oh,
Okay. And on the top, I have 4 minus x plus 4. And this is all times 1 over x. We okay with that? No, those x plus 4s do not cancel out. Okay, they don't cancel out. You have that minus sign there in the middle and the top. Can't cancel out. The only way they can cancel out is if they were being multiplied. So I try simplifying the top and seeing where that gets me. So the limit as x goes to 0 of 4 minus x minus 4 over 4 times x plus 4 all times 1 over x.
So that's just negative x up there.
That's just a negative x up there? You sure?
Well, when you say it like that, no.
So these 4's cancel out.
Okay, yeah, sure.
Okay, you were right. Okay. I'm left with a negative x on top. What about that x's? Negative x on top, 1 over x off to the side. This x and that x will cancel out with each other as well. Right? Is everybody okay with that? You want me to write this separately or can I keep going? Like within this step? Separately? Okay, that's fine. So the limit as x goes to 0 of negative x over 4.
By the limit of x equals.
Yes,
Are you serious?
dead serious.
That's crap.
Because we haven't found the limit yet.
Will you dock his points if you don't write it?
Yes.
Oh my gosh.
You have to write that every time until you actually evaluate the limit. We haven't evaluated a limit yet. You need to keep that going on every line.
That's not so spicy.
Okay? So, like I just said, we have this negative x on top and we have this x on the bottom. They can cross-reduce, right? To get a negative 1 on top. The reason it's negative 1 is because it's a negative x, right? Negative x divided by x is negative 1. So I have the limit as x goes to 0 of negative 1 over 4 times, I don't like that.
It's funky.
I know. It like caught my wrist or something. I don't know. 4 times x plus 4. Okay, do I have it simplified as much as I can?
Yeah.
Okay, so we try plugging in 0. Negative 1 over 4 times 0 plus 4.
Don't forget to go to x plus 0.
No, I'm evaluating now. I plugged in 0. I'm doing direct substitution now, so now I don't need it anymore. What does this equal? Negative 1/16. There's my answer.